All right, good morning, folks. It seems like you're in between me and lunch next. So let's try to make it as productive as we can and mind your hungry butterflies hanging around your stomach. And we'll make it as exciting as possible. So my name is Sunil, and I'm the Principal Program Manager, leads the Azure database for PostgreSQL service on Azure. And today, my objective is, first of all, to give you a brief overview of what we have done with Postgres, and then leave with demonstrating a powerful, intelligent app powered with PostgreSQL, and how do we go about doing that on the Postgres on the Azure environment. So before I go any further, it's important to call out, and as we have gone through the keynotes this morning, if you have to take away one key learning, it's pretty evident that it's an era of open innovation, right? It started with developing software in the open source, and specifically on the database side, led by MySQL. And fast forward 2 decades later, we now see ourselves with Postgres being the fastest growing relational database, or I should say database, in the open source world. And that's a huge shift, and if you will, in terms of how we see innovation happening around us, and how open source alongside with cloud actually helping and working together to make things happen. And when you put this into the context of Microsoft and Azure specifically, for us, it's all about listening to customers and building solutions that best solve their problems. And what we have seen, and it's the same listening process that has gotten us to where we are today, and why I'm honored and I'm proud to be in front of you all talking about Postgres and Microsoft and Azure. So with that, let me give you a little bit of a peek into the feedback that has been coming into us as we were doing the listening process. Because for us, the first part of any journey is to listen to what customers want. And the proven way for us is being the Microsoft user voice, which is a platform that we pay a lot of attention to and take it very seriously. And at many times we've seen, as you can see, like at one point in time, it was the third most demanded service for Microsoft in the database services area, right? And that did not happen overnight. And there's been a lot of requests from a lot of variety of existing customers and also potential new customers that were looking into Azure as a platform, as a cloud platform to build their applications, and they were looking at, do we have Postgres? And then it was also very interesting for us as our friends in Google announced their private preview of PostgreSQL, we hit the charts again in Hacker News. The question was, when is Azure going to introduce Postgres? So it's flattering. It's been flattering for us, and quite a good journey. And it's quite good to see the major cloud vendors now fully coming behind Postgres as the database and making the ecosystem around Postgres vibrant and even better. And that's precisely our goal as participating in this community and participating in this PostgreSQL database, is not just to take whatever Postgres that's built by the community, put it on the host, put it on the cloud, build a managed service wrapper, and then say goodbye, or say, customers, you're on your own. For us, it's now a beginning of a journey where we want to make Azure the best cloud platform to build applications powered with Postgres. And not just looking at the database particularly and leaving it at the database, because database is just a means to an end. When an app developer builds an application, of course he needs a database to store its data. But then the question is, as the application grows, as the data, as you need to drive new analytics, you want to do new machine learning, you want to do predictive analytics, you want to expand the horizon of the application. How do you best do that on the Azure platform is going to be the primary focus on how we are going to fuel and make Postgres popular on the Azure platform. Now, once we start the learning journey, before you go and start to assume what the problems are, you need to listen in terms of what the real customer pain points are. Where is the database developer? What are the key challenges that they're having? What about the application developer? Because it's always about the app. As much as we in the database can come stand here and say it's all about the database, the application developer will come and say it's all about the app. And you have to serve both the constituents in a fair and square way, so that you are, when you're creating the solution, you're meeting the demands and requirements of both. So when we went and talk about the database developer, when we go and talk to the database developers, and for us, knowing about the database developers is not something new. This is what Microsoft has been doing for decades with the SQL Server business. And we know a bit of too around what database developers need. And when we go and talk to the database developers, when we revisited that conversation with customers that are developing and are managing databases with open source databases, particularly Postgres, these were some of the core requirements that they came out as saying, this is very critical for me to manage on a day-to-day basis. And the first one, of course, is the most common one that we hear from all the database developers: infrastructure patching and upgrades. Why am I spending my time in doing infrastructure updates and managing my databases this is not critical, it's not interesting, it's boring work? Why am I doing my boring work all the time? Well, database availability, of course, right? It's a no-brainer. And then backups and recovery. And then what if at the midnight, as it's happened, and we've all heard on the news a couple of, like a year or two ago, like a database developer wakes up in the midnight or gets called in the midnight, he's half asleep, he wants to do some operation, his fat finger goes and hits on delete. And now what do you do next, right? So, and then making sure that, okay, I do all my backups, I'm a very good DBA, but for all the backups that I've taken, is it recoverable? How do I know I can use the backup when I need it, right? And that always is at the back of your mind. You take your backups, you follow all the processes, but one fine day when things do happen, and things do happen, and what can you recover the database? Security. Right, and the database, which is powering most of the application, is storing a lot of sensitive PII data. Now, how do I make sure that I can guarantee to my users of the application that uses the database that the data is secured and nobody is breaching or stealing that data? Because that's your reputation of your application or your reputation of your business is squarely on how you're protecting that customer data. And then the real meat of the database developer, which is what they would like to focus the most, and that is optimizing the performance. That's where the value is added. And now, how do you make that experience better? How do you make that easier? How do you make sure that with hundreds of metrics that you can collect on the database and another 100 that you can collect on the infrastructure and then the network and all the stacks, and then now you have to put all these puzzles together and then figure out, oh my God, where my problem is. You perhaps, if you're a startup, you're out of business. Or you've spent enough money from your budget that you don't have money left to innovate on your app. Right? So how do you make that experience better so that you're really making and you're ensuring that database developers are able to do this efficiently, fast, and go at the pace of what the business wants them to go? Now you flip the coin, and then we talk about the application developer. It's related requirements, but are also slightly different, right? They have a different mindset. For them, it's all about, okay, I need a simple one-click button that I can go and provision at my ease. It just needs to happen. I don't care about what the database is. It just needs to work. It needs to do whatever it's supposed to do, right? And then, yeah, availability is important, security is important, performance is important. But don't give me that, oh, I'll give you the best security, but I cannot give you the best performance. Or I'll give you the best performance, but hey, I can be a little bit lax on security. It's really what they're asking is a no compromise security, availability, and performance. And they mean it when they say that. And then performance management. This has been the biggest challenge for any application developer, and for decades. I've done applications in the past, from the database, like being a database guy for over decades, and then when you go and meet to an application developer, it's always about, okay, how do I know how much performance do I need? How many resources do I need to configure? Right? Okay, I don't know. Okay, let me over provision by 10 times. Do I have the budget for it? No. Then do I know my application is going to be successful? I don't know. So where do you start? Then the question then is, if you give them a simple, easy way to actually deploy with whatever arbitrary amount of resources they think they need, and then be able to scale up and down at ease without the pain point, then essentially you are saying, okay, doesn't matter, just move on. Start your application with whatever the bare minimal resources that's required, and if you're learning that, okay, it needs more, add more. It doesn't take a lot of pain. And then, of course, developers never want to give up their freedom, right? App developers specifically. They don't want to give up their freedom. They want to use whatever tools they want, whatever the languages they like, whatever the frameworks they like, because they are focused in the task in hand. They're not religious folks that says, I shall only code on Node.js, or I shall only code on Python, or I shall only code on Perl. Developers are all different flavors. And for them, based on what the application that they want to get done, they go and search, maybe Google, maybe Bing. And then they find, okay, it seems like 50% of the work is already done and is coded in some language. I don't care. I think I know that language. Let me borrow that 50%, and then let me go and build the 50% on top. So it's always about the freedom of the developer choice. It has to work with every language, any language, whatever tools, whatever is the most common or used or not. They want to have that freedom. And then, of course, they are very stingy. I mean, of course, why not? We are all stingy, right? Who wants to spend more money than necessary? So so they want to start small. They want to grow as their business grows, or the app becomes virally successful, and then scale back when their app is not doing much, right? So flexible pay-as-you-go pricing. Okay, so we listened and we learned the data. We learned the pain points. Now the hard work in designing. All right, how do we go build a service, right? Okay, so before I go into the details, important to set the context in terms of, okay, I mean, Microsoft and Azure has been having the Azure SQL database service for multiple years. We have built a platform in terms of how do we build a managed service around it. It's been powering SQL database and Azure SQL data warehouse for, like as I said, for 6 years. Now there are two approaches for us. I mean, either go build, reinvent the wheel and go and do something special for Postgres, or we go leverage the platform and the learnings that come from the platform for multiple years and then extend it to actually make Postgres the first-class native citizen of that platform. And that's exactly the route that we took. And the motivation behind that is bringing the same innovations that has gone into powering the Azure SQL database and data warehouse and bringing it into the Postgres environment cheaply and easily, right? And that also from an end user perspective, it means now you get the same enterprise level security, resource governance, isolation, et cetera, onto the Postgres environment and making Postgres enterprise ready within the Azure platform. So this platform is built to be intelligent, trusted, and flexible. Trusted is basically a synonym for saying security, because all of these capabilities are built into the platform, built as microservices, sitting on top of the Azure Storage and Azure Compute and the Azure Service Fabric. And when I talk about the architecture, you'll get a little bit more peek into this. And we started the preview journey in May. So when did the session in Postgres Vision back in July, that was the first one since the announce, the preview announced. So we have been in preview for a little less than like 3-4 months. And these 3-4 months has been quite humbling in terms of the number of developers and the number of users that are coming in now, playing and evaluating the service, and we learned quite a bit from the user feedback. So next, before I get into the, again, getting into the architecture a bit more so that you understand how we've gone about building the service, it's important I know how many people are familiar with the Azure constructs and the Azure things? Okay, 2 out of, like, I guess, okay, you're the minority. So I have to still yet go and talk about this slide. And this is basically the synopsis in terms of how you think about creating a resource in Azure. So of course you need to have an account, right? So account is basically your credit card. And then you have subscriptions. And then you have resource groups. A resource group is basically a collection of all the resources. Think about resource as a service in this case. So when you create a Postgres server, it's a resource. When you create a compute VM, it's a resource. And what we have is a server model, and it's a logical, but not bound to a physical server. So this service is not hosted on like I say, a virtual machine. It's a secure isolation container-based model designed to be highly efficient in performance. It also is the connection endpoint to the Postgres database that you create. You can create one-to-many databases within the PostgreSQL server. And the policy scope in terms of management, monitoring, backup and recovery, et cetera, is all at the server instance level. Right? So we'll get to learn more about this when I talk a little bit more about the architecture. So let me take a little bit deeper dive into this slide. So this says how to create, connect, and manage PostgreSQL Server. Now, as I said, when you create a server, it's basically the endpoint for the connection. It's pinned to a specific region in which you create the server. So in this case, you see on the right side of the box, you see the server is being created in US West. And the service has 2 components. One is the control plane and one is the data plane. All the provisioning and management operations happen through the control plane. And you go about managing and provisioning through RESTful APIs that is exposed via the Azure Resource Manager. The Azure Resource Manager is the common way in which you provision and manage resources across all of Azure resources. Right? So it gives you commonality in terms of billing and auditing and all other the good stuff that happens at the global Azure Resource Group level. So, as I said before, like when you create a PostgreSQL server, you get one database, like Postgres database created by default, and you can create one-to-many databases. We do not have any restrictions or limitations in terms of how many databases you can create. You can create as much as you want. You want to create 1,000 databases? Feel free. The only caveat and the only criteria you need to keep in mind is how much resources have you created your server with. And all the databases that you create within the instance share the available resources. Now so the Azure Resource Manager also is responsible for creating the new experiences on top. For example, building through the portal, giving you the portal experience and giving you the Azure CLI experience if you are a command line person like myself, or if you want to integrate with any other third-party automation tools like Terraform, for instance, Chef, Puppet, etc. You can go do that as well, leveraging those ARM APIs. The data plane operations is simple. We use the same common Postgres protocol. We're using the same. We're using the the community editions of Postgres. We support Postgres 9.5 and 9.6 to date. And it talks the same common protocol. Therefore, any of the existing applications or the existing Postgres 9.5 or 9.6 databases that you may be hosting anywhere, be it on-prem or in a desktop or a laptop or anywhere in the cloud and in an infrastructure service or wherever, can work seamlessly without changing any line of code. Well, one line of code, you have to change the connection string, right? And it is expected to work. And the same goes with all the existing tools as well. If you are used to and want to use pgadmin, you want to use a pSQL, you want to use any other third-party tools, so long as those tools are compatible, talk the same protocol, it all would work. And that's the promise. Now, as we went about creating the service, and this is one of the benefits of the data platform architecture that we had built, which was powering the Azure SQL database and data warehouse, as I was talking about before. And that platform was built to provide out-of-the-box built-in HA. What does that mean? That means you don't need to create any replicas to maintain availability. Now, is that suitable for 100%? No. But for more than 80% of those apps or the applications that can withstand tens of seconds of downtime, you don't need to maintain another replica and manage those replicas. And the way we're able to do that is a client that talks to the gateway. So in our architecture, we have a gateway, which also acts as a connection proxy. So it proxies all the connections that are coming from the application. So the client talks to the gateway, and the gateway resolves which is the backend database in the backend node that database resides in, and then connects to that database. Now, in the event that database were to go down, our provisioning layer, our control plane, would quickly provision a new instance. And since we are using a container-based approach, don't confuse it as a Docker container, so it's a secure isolated process-based container. We are able to spin that in seconds. And then the client then retries the connection, and then the gateway resolves, and now it's connecting to the new instance, creating a new node. So all this happens with virtually no application downtime. I mean, no application downtime is here only means that the outage is, or the downtime you can count is in seconds, tens of seconds, not minutes. And serves the majority of the use cases, I would say 80% of the use cases, where they don't want to maintain replica and pay 2 times the cost for maintaining the availability. Now, while I'm on this topic, so as I said, like we talked through the gateway, so all the connections are proxied at the gateway. We have one of the issue, or one of the byproduct of that is increased latency. So all traffic, client server communication is going through the gateway. And for this, we also have created connection redirection, which means like we have an ability for the client to talk to the database directly, eliminating the gateway as well. And that is also suitable for many of the use cases that are sensitive to network latencies. Now, if you remember, I talked about the application developer wanting to have a simple, flexible scaling. That is, if scaling up or down is so seamless and simple, then I can pretty much eliminate the pain rather than trying to see how best I can address the pain, right? So the best solution for any problem is make the solution go away, right? And that's exactly the kind of philosophy we have here as well. Make the scaling fast and seamless, and then take performance management monkey out of your way, or give it to somebody else that wants to do this on-prem. So let me demonstrate how the scaling the performance on the fly works. So same as I explained, so you have the client connecting to the gateway, connect to the database. All right, my database is now running out of juice, and therefore I need to kind of scale up. Okay, so now begins the fun part. So when you scale up, Now you have a bigger box, a bigger cylinder, I would say, right? While this new cylinder has been created, or like while the new database, the scaled up instance is being created, the connections are already all like still going on with the old one. So you don't have any application outage at this time. Right? So the time it takes to create this new instance is pretty much out of your critical path in terms of the overall end-to-end latency in terms of completing the scale-up operation. Now, so now, after this instance is created, so what we do is we detach the storage from the old one, and this is when you start to have the outage. And this is the minimal downtime, right? So we detach the remote storage, and then you attach the remote storage, and after the attach of the remote storage, you'll have to do the normal Postgres recovery, depending upon how many ever in-flight transactions you had at the time when the detached storage operation took place. That will define how much total end-to-end elapsed time it will take for you to complete the scale-up operation. And even this is optimized such that so that it is minimized. So we minimize the amount of recovery that needs to go on top, so that the total amount of time it takes to go complete the scale-up operation is in tens of seconds. Again, similar timing as how much it would take for you with the built-in HE I talked about. Right? It's measured in tens of seconds, typically 30 to 40 seconds. And during this process, the client is expected to have this connection retry logic and trying to connect to the database. It says, okay, I'm not available, and once that's available, it's now able to transparently connect back to the new scaled up instance. This is how the scaling on the fly on our service works. Virtually no application downtime. So we talked about security. So we have 3 axes of security, right? The first is the identity. So we use the common native Postgres authentication. So whatever the authentication methods that you're using in Postgres, we support that out of the box seamlessly. Then we have our access controls with 2 key defense mechanisms. One is through the secure SSL connectivity. That means all client connections by default connect to the database through SSL. Optionally, we allow you to disable it, much to our dislike. But there are multiple open source applications out there that do not support SSL natively out of the box. So we had to do that with regret. But it's in the spirit of meeting where the application developers are or where the ecosystem is, we had to provide an ability to also optionally disable it if the application stack or the framework that is in use does not support SSL as a first-class connectivity method. Secondly, we have the server firewall rules. That means any client app that needs to connect to the Postgres server needs to be whitelisted or needs to be configured on the servers. For those Postgres experts, you know that this is the common HBA conf that we all know about, where we have this whole notion about whitelisting the IP address so that you can open up the connection between the client and the database. And thirdly, on security, an important one is encryption of data on disk and at rest. And I mean, all data, including the backups, are by default encrypted on disk using AES 256-bit, implemented on the backend storage. You cannot disable it. There's no optional switch to disable it. It's enabled by default, keeps on by default all the time, both data and backups. Okay, so now let's go through the laundry list of things in terms of solving and trying to kind of close the point in terms of the key developer pain points and how we're solving those pain points. So first, for the database developers. So we said, okay, security and making sure that the customer PI data that is stored in these databases are always secure. As I explained, all data, including backups, are by default encrypted on disk using the AES 256-bit encryption. Connections are secured by default using SSL, and we make it simple such that you don't have to, or the end user doesn't have to use his brain whether he needs to switch on or off. It's on always. Okay, so it's simple. Backups. So we have built-in backups, ability to point-in-time restore to any time up to 35 days with a recovery point objective of less than 5 minutes. And also, importantly, backups are geo-redundantly backed up. That means in case you have like a region outage, you can still recover from, you have an ability to recover from a geo-redundant backup. And this can be another poor man's, I wouldn't say, let's say like a stingy developer like myself, I can live with this type of disaster recovery strategy, right? So 1 in a million, or 1 in like, what's the probability of this happening? And okay, if that does happen 1 in like 100 years or 20 years, then I have something cheap. Then we talked about monitoring, troubleshooting, and so on. So the service provides monitoring for metrics up to 30 days free of cost. That means you don't have to pay any additional for storing the metrics and capturing the historical metrics, which is provided at a minute granular level, and is preserved in the backend history for up to 30 days. You can, we also give you access to server logs. You can configure the retention period of the server logs for up to 7 days. You can dial it down if you think that your configured storage is running out of capacity very soon because you have the highest verbose level of logging, then you can dial it down, and then when you can basically tune up and down. And then we have also by default enabled pgstat statements so that you have always access to the Postgres metrics if you need to. Right? So it's not optional. Out of the box, when I'm a developer, there's something going on. Oh, did I forget to enable this pgstat statement extension? No, you don't have to do that. So it's enabled by default. So this makes it simple for developers, like no-brainer things that yes looks like no-brainer, but always is a oops thing when after the event. We make that job simple. And this goes to, again, listening to the key pain points developers have and these database developers have, making sure that they don't have to think twice and what to do and what not to do. If it's a best practice, you have to do it, we do it for you. Automated patching. So another thing we said as a key pain point for database developer is managing updates. Like, okay, we get minor version updates every 3 months from Postgres, and then we also have infrastructure updates, the service fabric and the security patches and so on. Now, all of that is orchestrated and managed by us out of the box. We don't give you a switch to say, okay, configure a window whenever you want to do this. We do it intelligently behind the scenes for you, so rest assured, for the end user, it means that I'm running the latest version, I'm running the most secure version, and I'm protected, right? So that's the philosophy, that's the intent, making sure that all the databases are getting the patches that they need, right in the right time, at the right moment. And server parameters. So if you want to go play with some server parameters, I know Postgres has a lot of server parameters that you can customize. We have controlled access to many of them, and this is a journey that we are starting. And I say it's like we have a point of view in terms of how we want to look at server parameters and not give any server parameter back directly into the hands of the customer or the end user that can basically actually make it worse for them. So as a managed service, if the intent is it should just work, then you shouldn't be able to fiddle with like hundreds of parameters. But we recognize that there is a fine line to be drawn. There's a balance to be drawn in terms of which parameters are really useful, helpful, and least possible for customers to trip themselves, versus those that we know if you give it in the hands of the customer, we know that they will trip and they will fall, right? So that we want to protect, because we want to make sure that developers that are relying on Postgres database have the best experience. So while we have a lot of parameters that we opened up, and we are continuing to open up a few more, we are doing that selectively based on user feedback and knowing what harm it could potentially make versus what benefit it could potentially make. So it's basically the risk-reward analysis that we do and making before we willy-nilly go and open up all the parameters and say, okay, this is the floodgate, go do whatever you want, and hit yourself under the foot. And then, of course, how can we forget about the extension? So we support about 23 extensions out of the box today. Most of the popular extensions are enabled, and of course, there is never an end to the extension world. So that means this is a never-ending story in terms of adding and continuing to enhance and add more and more and more extensions going forward. And this is something that we take user feedback very, very seriously. So if a user comes to us and says, I can't get my app running because you don't have this extension, all right, point taken, and we will add that extension. Okay, now leave the database developers aside. Let's go to the application developers. Yeah, to balance both these constituents, they are both important. So from the app developer's perspective, it's all about focusing on making their apps great, right? Deploy database in minutes, and I need, like as I said, no compromise, availability, security, and performance. They don't want to compromise on any of these aspects. One of the three or two of the three will not do it. And also, if I can prevent me from going and setting up new replicas and all that stuff for management, right? And as I start my app journey, and yes, I have an app that connects with the database, but okay, well, tell me what else can I do? How else is this integrated with the rest of the Azure services and the Azure platform so that I can go and build rich, intelligent apps? And this, I talked about the freedom, right? And repeating the same thing again. I want to be working in my environment. If I have a favorite tool that I use, if I have a favorite language that I want to use, it should work as is. So the service out of the box guarantees that, yes, whatever the stacks that we have and whatever the Postgres community supports, we will support it out of the box as a first-class language and a first-class tool. And I talked about performance management. If you have the ability to be able to scale the performance on the fly, then performance management and doing my work in terms of predicting what level of performance will I get before I know the performance, before I know whether the application is going to be successful or not, is, I mean, takes the big challenge and issue out of your way. So you can scale compute and storage independently. And all the benefits that I talked to you about, no additional costs. Simple, inclusive pricing. Which means no, oh, I'll charge you 10 cents for this, or I'll charge you 5 cents for that. I'll nickel and dime you here and there, right? Because developers don't want, they want a predictable bill. Okay, I'm stingy. I go by my reference. I'm a stingy guy, so I need to know, I need to have predictability in terms of how much am I going to pay every month. So that's what it's been, our pricing model, and how we have looked at building all the capabilities is making sure that all of that is included in just one price that you pay for compute and one price that you pay for storage. Okay, so I said we launched preview back in May, right? And since then we are actively working towards enhancing, and I'm very proud to say that we are now SOC 2 certified. We've expanded on the regions. We are now available in 13 regions. We were at 11 regions. So I've added India to the preview regions as well. So right now at this point we are in India, we are in US, we are in Europe, we are in Asia, and we are in Japan. So, and this region list will continue to increase over time. And our goal is by the general availability timeframe, we will be in all Azure public cloud regions, which is about 34 regions. I know you have the question, when will we GA, but I did not answer that on purpose. So we kept ourselves updated with the minor versions. Like as I said, out of the box, you may know, you may not know. So, and this is and then we enable several parameters like work mem and temp buffers. So this is what we learned from working with customers, that these parameters have a huge impact in terms of potentially improving the performance, and sometimes an upwards of 10 times. And what was not allowed to be customized before, we enabled it based on the customer feedback. So it's another example of, like, we want to hear feedback from customers, and then when warranted, we want to make sure that we are doing the right thing. It's not a philosophical debate in Microsoft that we shall not. It's not about we shall not. Okay.
A quick question. Could you go back to that slide?
Yeah.
Could you just expand on the last two bullet points?
Yes, so the standard tier, so we have basic and standard tier. So the standard tier is available now in Asia and Europe, and we are looking into making it available in all preview regions by in less than a week.
What's the tangible difference between the tiers?
The tangible difference between the tiers is essentially in terms of how much storage performance you get and how much you can scale the performance of the compute. So for example, basic will scale up to a single core of performance, and standard at this moment will scale up to 8 cores worth of compute. And also the fact that the standard tier uses faster remote storage backed by SSDs, whereas the basic is using magnetic disk-based remote storage. So if you need more predictable storage performance and more predictable compute performance and scale the performance, you would typically use the standard tier.
And storage scaling, what's not there now?
The storage scaling, I mean, you can configure up to a terabyte of storage today. We are continuously working to add more storage options. And what I'm talking about here is being able to dynamically scale storage, similar to how you can scale up and down the compute. That capability is going to come pretty soon, in a matter of a couple of weeks. And today, to answer your specific question, the storage increments is in 125 gigabyte chunks. Okay. So I do want to talk about how to go and build an intelligent app, because all of this conversation is not very meaningful if you don't know what you can do with this Postgres database. So with that, how many of you invest in stocks? I guess all. Perhaps maybe you will go rich today, but don't hold me accountable if you don't, right? So I'm going to run an app that basically will predict the stock price for the next day based on machine learning, algorithms, and cognitive APIs using the Twitter sentiment scores. So what this demo app is doing is that we are pulling in about 1.6 million tweets coming from our identified 3,000 investors that we are tracking. We believe these 3,000 investors are really good indicators and their sentiments are good indicators of what the future pricing is. And then we're putting and hosting them into the Postgres database. Once it's in the Postgres database, now we're going to start to do something more meaningful with it, right? Now I have the data, so let me go and do something interesting with the data. So I'm going to call the Cortana Intelligence Suite. I think everybody understands Cortana on the Microsoft. And that is about trying to extract a sentiment score from each individual tweet. So the score could be anywhere from 0 to 1. 0, bad score, very, very negative, and 1, excellent, positive tweet. Typically, you want to make sure that if anything between 0.4 and 0.7 is considered as like an average tweet, average sentiment, and anything above 0.7 is considered as a very positive tweet. So the Twitter feeds that are coming in from these recognized 3,000 investors are going into are being pulled by the cognitive text API from Cortana to establish a sentiment score. And then we have also used the Azure Machine Learning Studio to develop a machine learning model with 2 years old worth of data, with the stock data, the high price, the low price, the volumes, and the sentiments, and then run predictive experiments. So we have trained this machine learning with different algorithms. So you can basically take all the data, and then you can say, okay, I want to go and run a Bayesian regression model on this data. Or I want to run a decision forest regression model. And there are many regression models and data modeling algorithms that you can take your historical data, and then depending upon how accurate they're able to predict, you can keep changing it like every day if you want. right? So one day you might say, okay, Bayesian is giving me a better prediction. Another day you can say, decision forest regression model is giving me a better result. And then once I have all this figured out, now I want to have a very nice, pretty dashboard that tells me, okay, what my prediction model for the stock is going to be for the next subsequent day. All right, let's go to the action. So first thing, so what you find here, why is it not going? Oh, maybe I think I know why. I need help. Interesting. I can't even show my screen. Okay, while we have the technician come in. So let me show you how we have kind of built this all together, right? So on the left, you see that we have a web job which is essentially written in C#, that is pulling the tweets from the Twitter using the tweet env command API, and that web job written in C# through the PostgreSQL, which is the driver to connect a .NET application into Postgres, is inserting those tweets into the Postgres database. Now, once the tweets are put into the Postgres database, the Cortana Intelligence Suite with the Text Analytics API is extracting these tweets and then creating the sentiment score for each of these tweets, and then putting that sentiment score back into the database and creating another column with the schema. So once the sentiment score is established for each of the tweets, like as I said, then we push it to perform the predictive modeling experiment through the Azure Machine Learning Studio, which has been trained with 2 years old of historical data. So we then send the tweets with the sentiment score for each of the tweets, and then we get the prediction score that is again persisted into the Postgres database, which is then used to connect to the Power BI connector via the Power BI connector, again through the PostgreSQL. Now you're able to visualize what the future or the next day price for that tweet is going to be. Okay. Now let's see whether this magically starts to work now. You know what's happening?
What are you trying to display? Is it
Another browser.
a browser?
Yeah. It seems like it only likes PowerPoint.
It should be mirroring your computer, exactly. Where's your browser? That's not showing on there. It's your So your display should be set in mirror, which should be set in both anything on your desktop, anything on Windows. There we go. Tucked in there. There it is. It's up there now. Is that on? You extended it?
Okay, back in action, which I guess is what you were waiting for. So what you see here is like I'm profiling on Microsoft. I have Amazon, Facebook, Google as well. I'm just trying to be nice. And what you see on the second chart is basically what is the stock price of that going to be the next day. And what this is predicting is that by end of day today, the stock for Microsoft is going to be 74.2. So we can have a beer at 4 or 5 o'clock if that happens to be true. So now I have to bring my mouse. Going to be a bit difficult. So this is the database. So what you see is like 4 queries that I'm running against the database. The first one is trying to, the query that I have run is going to give you all the stock, all the tweets that I've followed or gotten from the 3,000 plus investors. It's about 1.6 million tweets. And then the second one, now if I can. So now you see that there is a sentiment score, the second last column on the right, that has the sentiment score associated with each of the tweet. I know we're running out of time, so since I'm all making you rich, so I think I can grab a few minutes. Okay. Now, this is difficult because I can't see this in my screen. Okay, so now what we have done is we have taken all the high price, the low price, and all the stock metadata from Google Finance API and persisted into the database and associated with the daily average sentiment score for each of the tweets. And finally, this is the query that if I run will give me the prediction of what the stock price is going to be for tomorrow. So to see that, do you see the stock price for tomorrow there on the top right? I can't see it. Yeah, it's 74.21, the first line on top. Right? So this is an example of how taking Postgres as the system of record now through all these rich APIs, the cognitive APIs, and also the machine learning studio to train your models with the data, all through the open source APIs, and then running a predictive experiment using the machine learning studio. Now I can get all of this running in Azure, and guess how much am I paying for this? This is actually a live running application. I pay less than $100 for all of this together. Right? In less than $100, and I could be making a lot of money with this. Right? Okay, so I know we are running out of time, and if I can get back my display. Now I guess I need to do the similar treatment to extend screen. And okay. So we have had a lot of customer success. I mean, I'm not going to belabor this point. You can obviously look at this on our website, and I'm going to urge you to go and try and give us the feedback. That's the most important factor that drives what we're going to be doing next. And that's what we've been doing all this while. And I'll leave you also with some of the resources as well in terms of the links and the Twitter handles. And if you want to tweet about us, if you want to ask questions, there is user voice, which I talked about earlier as I began my presentation. Give us your feedback. Let us hear your voice in terms of how we can make it better. All right, questions?
And you said you don't need to create replicas and so on, so all the high availability is taken care of. But typically, the applications need things like load balancing, so you need to send some read-only queries off to the replica and things
Yeah.
like that.
Yeah.
So would you be able to support that? Would I be able to get your high availability along with the inbuilt Postgres replica and things like that?
Yes, that's a great question. So when I meant like you don't have to have replicas, you don't have to maintain replicas just for maintaining availability. So right. So of course there is requirements, or there are scenarios where you want to scale for reads, and readable replicas, etc., become important. And that is part of our roadmap, as part of our journey, as we are looking into making it available in subsequent months. But it's not available as of today. We are, again, based on the user voice, we are prioritizing what we have to do next in terms of like gaining the feedback. But yes, the readable replica is very high in the list of things that many users have asked for, and it's part of our roadmap. Any other questions? I know there are butterflies in your stomach, so thank you so much, and appreciate you all being here, and look forward to seeing you all at the reception and also at our booth. Thank you so much.